Hello, Pam. What's the matter?
I'm thinking about my best friend's birthday. I want to order pizza worth 125 pesos. And her birthday is 7 days from now. So, I'll make an alakan siya. I'm going to save my money using this pattern. How much will I save 7 days from now? Can you help me, Teacher Yang?
Of course! We will help you, right, students?
Hello, students. I am Teacher Harriet Camino. You can call me Teacher Yang. I am your teacher in mathematics. Let us learn together because math matters. Our learning objective is finding the sum of finite geometric sequence. So prepare your pen or pencil, paper, and your modules for this lesson. Let's get started. Let's go! What's in? In this part, you already know what is geometric sequence. Now let us review some previous lessons. Determine whether the following geometric sequence is finite or infinite. If it is finite geometric sequence, find the common ratio. If it is infinite geometric sequence, find the next term. Did you get the correct answer? Okay, that's right. Finite geometric sequence are numbers 1 and 3 because they only have 4 and 5 terms respectively. They are countable terms. In number 1, the common ratio is 3. In number 3, the common ratio is, yes, 0.5 or 1.5. Good job. The remaining numbers, such number 2 and number 4, they belong to infinite geometric sequence. You can easily identify them by this ellipsis. In number 2, the next n term of 4, 20, 100, 500 is, yes, 2,500. In number 4, the next n term of 125, 25, 5, 1 is, yes, 1/5. That's correct. What's new? In this part, we will explore our new lesson. What is finite geometric series form? Finite geometric series is a sum of countable geometric sequence. For example, write the first 7 terms of a geometric sequence 1, 2, 4, 8, 16, 32. That is, S sub 7 is equal to 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64. You'll just need to replace the comma into addition symbol. Another example. Write into geometric series form the first 4 terms of geometric sequence 1, 3, 9, 27, 81. That is, S sub 4 is equal to 1 plus 3 plus 9 plus 27. Okay? Do you got it? Now, let us try to solve Pam's Ipon challenge. She saved her money geometrically as what can you see in the table. She saved her money on day 1, 1 peso. On day 2, 2 pesos. On day 3, 4 pesos until day 7. What is the total of her savings from day 1 to day 7? Let us write it into geometric series form. First 7 days of saving. Let S is equal to sum of money n is the number of days. That is, S sub n is equal to S sub 7 is equal to 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64. We can manually sum up them all. S sub 7 is equal to 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 is equal to 127. S sub 7 is equal to 127. Easy, right? And yes, it is easier to just add them in this example as there are only 7 terms. How about long-term savings? Imagine adding 50 terms or 365 terms. Then, formula is much easier. Formula. S sub n is equal to the product of a sub 1, quantity 1 minus r to the n divided by 1 minus r, where a sub 1 is the first term of geometric series, r is the common ratio, n is the number of terms. Now, we will try to use the formula in finding the sum of Palm's ipon challenge. Let's try to use the formula in finding the sum of Palm's ipon in geometric series form. 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64. Let us try to use the formula. First, let us identify the given. A sub 1 is equal to 1. That is our first term. The common or constant ratio is 2. Number of terms or n is 7. Now we substitute the given values. S sub 7 is equal to the product of 1, quantity 1 minus 2 to the 7 divided by 1 minus 2. Remember, in answering the expression, follow the PEMDAS rule. Evaluate the inner part. S sub 7 is equal to the product of 1, quantity 1 minus 2 to the 7 is equal to positive 128 divided by 1 minus 2. Next, S sub 7 is equal to the product of 1 minus 128 is equal to negative 127 divided by 1 minus 2 is equal to negative 1. Then, S sub 7 is equal to 1 times negative 127 is equal to negative 127 divided by negative 1. Negative 127 divided by negative 1 is equal to positive 127. Again, S sub 7 is equal to the product of 1, quantity 1 minus 128 divided by negative 1 is equal to 1 times negative 127 is equal to negative 127 divided by negative 1 is equal to positive 127. Palm's saving is 127. Remember, the pizza cost is 125 pesos. See, the formula works. Have you ever wondered? Now let us see how does the formula works in finding the sum of finite geometric sequence. For example, let S sub 5 be the geometric series of 2 plus 4 plus 8 plus 16 plus 32, where A is equal to 2, R is equal to 2, N is equal to 5. In the equation 1, multiply both sides with a common ratio 2. That is, 2 times S sub 5 is equal to 2 times 2 plus 2 times 4 plus 2 times 8 plus 2 times 16 plus 2 times 32. Now let us evaluate. 2 times S sub 5 is equal to 2S sub 5 is equal to 2 times 2 is equal to 4 plus 2 times 4 is equal to 8, plus 2 times 8 is equal to 16, plus 2 times 16 is equal to 32, plus 2 times 32 is equal to 64. That will be our equation number 2. Notice that each term of equation 2 is identical to those in the original equation or equation number 1. So, we will subtract 2s sub 5 from s sub 5. In subtracting equation 2 to equation 1, multiply equation 2 by negative 1. That is, negative 2s sub 5 is equal to negative 4 minus 8 minus 16 minus 32 minus 64. We have s sub 5 minus 2s sub 5 is equal to, bring down 2, 0, 0, 0, 0. Bring down negative 64. All this go! The difference is s sub 5 minus 2s sub 5 is equal to 2 minus 64. That is, negative s sub 5 is equal to negative 62. Multiply both sides by negative 1, we have s sub 5 is equal to positive 62. You can check it by adding 2 plus 4 plus 8 plus 16 plus 32. That is 62. In this example, we can derive a formula in general form. Let's do this, guys! This is the general expression of finite geometric sequence. To derive a formula, let us do the same steps from previous example. Equation 1. Multiply equation 1 by r. That is, r s sub n is equal to a sub 1 r plus a sub 1 r squared plus a sub 1 r cubed plus until a sub 1 r to the n minus 1 plus a sub 1 r to the n. Notice that equation 2 and equation 1 have similar terms, that is, a sub 1r plus a sub 1r squared plus a sub 1r cubed plus a sub 1r to the n negative 1 plus a sub 1r to the n. Now, subtract equation 2 from equation 1. We got s sub n minus r s sub n is equal to, bring down a sub 1, 0, 0, 0, 0. Bring down negative a sub 1 r to the n. So, the difference of the two equations is s sub n minus r s sub n is equal to a sub 1 minus a sub 1 r to the n. Notice that they have a common factor, s sub n and a sub 1. So, let us factor it out. To simplify the equation, factor both sides. On the left side, product of s sub n quantity 1 minus r. On the right side, product of a sub 1 quantity 1 minus r to the n. We got the simplified form. To derive the formula of s sub n, divide both sides by 1 minus r. Cancel. Tada! We get the formula! S sub n is equal to the product of a sub 1 quantity 1 minus r to the n divided by 1 minus r, where r is not equal to 1.
Is our topic helpful to you, Pam?
Yes, Teacher Yang, I was able to find the sum of my money, 127 pesos, and I still have extra 2 pesos for my next saving.